Welcome to The Explainer. Today, we're doing a rapid deep dive into the very engine of our economy: supply, demand, and market equilibrium. We're going beyond the basics here to unpack the precise analytical tools from Chapter 4 that dictate exactly why things cost what they do in dynamic, real-world environments. Let's get into it.
So, think about a simple ice cream cone. Who actually sets that price? Is it the shop owner? The dairy farmer? Or maybe, is it you, the customer? Well, it's actually a constant, completely silent negotiation between every single actor involved.
Here's our roadmap for today. We'll start with the law of demand, followed by the law of supply. Then we'll look at finding market equilibrium, dig into shifts and movements, and finally apply all of this to real-world market forces.
All right, part 1, the law of demand.
Let's isolate the buyer first. Take a look at Catherine's demand curve here. Notice the vertical axis is price and the horizontal axis is quantity. See that downward slope? That perfectly captures the law of demand. As the price drops from $3 down to 50 cents, she naturally wants to buy more ice cream. Assuming all other things are equal, when the price falls, the quantity demanded rises. It's a core, fundamental mechanic that holds true for pretty much everything we buy.
Moving right along to part 2, the law of supply. Now let's flip the perspective to the seller. Notice the upward slope of these supply curves. In direct contrast to demand, the law of supply dictates that as prices rise, sellers are highly incentivized to crank up production. I mean, think about it. If ice cream suddenly sells for $3 a scoop instead of 50 cents, producers are going to maximize their output. They'll work overtime, they'll buy more machines, all to capture that higher revenue. Higher prices simply mean a greater quantity supplied.
Which brings us to part 3, finding market equilibrium. So what happens when we smash these two competing forces together? We get equilibrium. This is a situation where the market price has reached the exact level at which the quantity supplied equals the quantity demanded. It's the theoretical perfect balance point of any market. Zero surplus, zero shortage.
You can literally spot the X marks the spot on this chart, right where the downward sloping demand curve intersects the upward sloping supply curve. Right at this specific intersection, which gives us an equilibrium price of $2 and an equilibrium quantity of 7 cones, everyone is happy. Buyers bought exactly what they wanted at that price, and sellers sold exactly what they wanted to sell. The market is perfectly clear.
But what happens when things get out of whack? Look at panel A on the left. If the price is artificially high, let's say $2.50, sellers want to make a ton of ice cream, but buyers just aren't buying it. Boom, you've got a surplus. Sellers now have freezers packed with product that can't move. So what do? They naturally lower their prices to attract customers, which drives the price right back down. On the flip side, over in panel B, if the price is too low, like $1.50, we get a shortage. Buyers are absolutely clamoring for cheap ice cream, forming long lines out the door. Sellers quickly realize they can raise prices without losing those sales, driving the price right back up. In free markets, prices act as this amazing, self-correcting mechanism that constantly steers us back toward equilibrium.
All right, part 4, shifts and movements.
Now, this is a notoriously tricky concept from Chapter 4, but it is absolutely vital for understanding market disruptions. A movement along the curve happens strictly because the price of the good itself changed. The line stays perfectly put, and we just slide up or down it. But a shift in the curve is a whole different beast. This happens when an outside factor changes how much people want to buy or sell at every given price. For example, if a massive heat wave makes everyone desperate for ice cream regardless of the cost, that entire demand line physically shifts to a completely new position on the graph.
To make sense of all this chaos, economists use a really practical 3-step toolkit for analyzing how real-world events change the market. Step 1, decide whether the event shifts the supply or the demand curve. Step 2, decide which direction that curve shifts. And step 3, compare the initial and the new equilibrium to see where things landed.
Let's actually walk through those 3 steps using a classic textbook example. Imagine a massive hurricane destroys a huge sugarcane crop, driving up the price of sugar. Sugar is, of course, a key input for making ice cream. So, step 1, does this affect supply or demand? Well, it affects supply because it now costs producers more to actually make the ice cream. Step 2, which direction does it shift? Because producing is now less profitable at any given price, sellers supply less, meaning the entire supply curve shifts to the left. And step 3, compare the equilibriums. That leftward shift forces the intersection point higher up the demand curve. The result, a higher equilibrium price for ice cream and a lower overall quantity sold.
And finally, part 5, real-world market forces.
Let's take these tools and apply them to a highly debated situation from our source material, natural disasters, like Hurricane Sandy. When a disaster strikes, we almost always see massive price spikes for essential goods. We're talking water, batteries, gasoline. Now, policymakers and the public usually object to these hikes, calling them price gouging, and a lot of jurisdictions outright ban the practice. But our source text presents an opinion piece that explores this exact scenario strictly through an economic lens, analyzing the market's natural, mechanical response.
The article highlights a pretty provocative question. Is price gouging reverse looting? When a store owner raises the price on batteries during a shortage, it feels incredibly unfair, right? However, the economic argument presented in the text suggests that trying to artificially prevent these spikes might actually cause more harm. Applying the mechanics of equilibrium we just learned, the author argues that if demand absolutely skyrockets, but the price is legally capped, it totally disrupts the balance and creates an immediate severe shortage. People might panic buy and hoard 10 packs of batteries, just in case, rather than the 2 they actually need, which leaves the shelves completely empty for everyone else.
The economic text further argues that freely floating prices, as painful as they are in the moment, actually force careful consumption. Plus, those high prices act as a massive incentive for outside suppliers to rush into the disaster zone to capture those profits, quickly increasing the overall supply. This leaves us with a truly fascinating question from the source to ponder. During a disaster shortage, would you prefer higher prices that guarantee goods are actually on the shelves, or standard prices but with an empty shelf lottery system where the first person takes everything? It's a profound challenge to our preconceived notions about fairness, scarcity, and that invisible hand of the market. Thank you so much for joining me on this explainer. I hope you walk away seeing the market just a little bit differently.